So, thank you. As you know, the organizers asked a few of us to prepare a second talk about the work that is done in our laboratories. So this will be my talk about FiEstIn, which is the division of statistical and interdisciplinary physics in Bariloche, this beautiful place that many of you know. This is not our laboratory. This is a 5-star hotel. Our premises are a little more modest. By the way, the monitos I told you yesterday live here in this forest, right next to the hotel. So we are a team of researchers and students, mostly physicists, plus a number of collaborators in the area of Bariloche, who are crucial in our interdisciplinary work. Some of them are ecologists, another are biologists, anthropologists, one archaeologist even. And, but the people that work at the Centro Atómico Bariloche, we are most of us physicists, plus we are now down to 10 members. The faculty are these people. You know probably several of them. Plus our graduate and undergraduate students that come and go and sometimes stay and some other times they return, as you know. We work at the campus of Centro Atómico Bariloche and the Instituto Balseiro, but all of us are also researchers of CONICET, and some teach at the other universities that there are now in Bariloche besides our institute, which are University of Rio Negro and University of Comahue. We work in our division at the intersection between statistical physics and other disciplines, as I mentioned, like biology, ecology, medicine, economics, informatics, and we are particularly interested in models of complex systems applicable both in nature and in society. And we can identify these 4 lines of work: mathematical biology, which is the thing that we are now calling physics of life, sociophysics and econophysics, which is like the anthropomorphic version of the mathematical biology, non-equilibrium physics, standard kosher physics, and complex systems. And I will tell you a little bit about each of these lines. And I will have to check my notes because I haven't memorized everything like Anna did. So I will have to read some of the things. So complex systems is a field that all of you are familiar with, where you have a collective behavior in systems formed by dynamical units with interactions. And one of the big paradigms in this kind of behavior is synchronization. And many of us have worked in synchronization in heterogeneous systems, in mechanical systems, in networks of communications, even with experimental applications with our colleagues from other laboratories in Centro Atómico Bariloche. So synchronization is one of the lines of works that have been active along the years in the field of complex systems. More recently, we have incorporated artificial intelligence and machine learning, development of algorithms with applications in specific problems, pattern detection in medical images, and in large volumes of data, and also in ecological problems, as I will mention further on. Mathematical biology, or the physics of life, as we call it from the physics side, is a field familiar to most of us. It is the use of techniques, as we have been seeing in the study of population dynamics, biological evolution, epidemiology, and this is a very active field. Most of us work in this line of work. Sociophysics and econophysics are like the anthropomorphic branch of the physics of life, with their own phenomena and peculiarities that depend on human peculiarities, including the natural languages, music, and the complexities of human economics. This is something that we have been doing also for a very long time in our work, for decades already. And finally, some of us still work in the hardcore physics, open quantum physics, fluid dynamics, etc. Less and less along the years. Instead of telling you details of each one of these things, I have chosen a few specific examples. Let me tell you a little bit about them. Most of them are the work that is being done by students nowadays, but the first one is by Laila Kazimierski. She's not a student anymore. She is the youngest member of our group. She is now the leader of a whole line of work. This is a spin-off of her doctoral thesis, which was the work that I told you yesterday. And that happened already 8 years ago. And she's working now in the design and development of machine learning embedded kits designed mainly for their use in monitoring and tracking of animals and their behavior. She is particularly interested in developing low-cost systems like this, accessible to our shallow pockets. And you can see here one of the systems mounted on the carcass of a tortoise. This is the thing that I mentioned yesterday after my talk. This was a spin-off of our work with the Monito de Monte. And you see these things have been developed and built by us. We buy the components and put them together. I think this was the prototype. It was mounted on a credit card, literally, soldered from underside. And then we made a circuit for it. Next, I selected Tomás González, who is a biologist, who is doing his PhD thesis in biology under the supervision of Fabiana Laguna and myself. He is developing a very nice model in epidemiology based on a study of an outbreak of mange that happened in a national park in the Andes that decimated a population of wild camels in the Andes. It is the system that I told you a little bit in December in Buenos Aires, for those of you that were there in Dynamics Days, about a mean field model of this. This was what I told. But Tomás is working on many more aspects of the problem, and it is very nice that he's a biologist, because his unique perspective has brought very interesting ideas that we never have as physicists. So he's doing a PhD in biology, but working under our supervision in our physics laboratory. Lorraine is also working on her thesis about an ecological system using tools familiar to all of us from statistical mechanics that allow to bridge the gap between the microscopic and the macroscopic deterministic laws. This is something that has been of interest of many of us along the years. perhaps because it's closely related to the way in which the macroscopic laws emerge in thermodynamics from statistical mechanics, for example. She's working in the formulation of master equations and for stochastic problems in ecological systems with predators and prey from a very abstract point of view. This is an example that combines epidemiology with the structure and dynamics of complex networks, something that I also worked years ago. This is by Eric Rosan, who is working with our colleague Marcelo Cooperman. He is particularly interested in managing outbreak of diseases with different incubation times. Well, he shows that different distribution of incubation times can affect the way that the epidemics can be forecasted. Alan Zambrano is close to finishing his thesis on the mathematical modeling and managing of ecological systems and resources and services. For example, he has a very nice piece of work on that combines phenomena of population dynamics with those of economics and social behavior applied to a king crab fishery in southern Chile. Despite his thesis title speaks of Valdez Peninsula, his nicest work was about the fishery of king crabs in the south of Chile, but as you know, these things can happen. And finally, I wanted to show you a little bit of the work of Lautaro Giordano. He's working with Fabiana Laguna on one of the models of economic systems. This is something that I started many years ago during a series of visits to Porto Alegre with our colleagues from Rio Grande do Sul. And later I stopped working on this kind of problems, but the line of work persisted in Bariloche, and now there are even students making her thesis on this kind of problems. They model markets, essentially, applying the framework of complex networks to classic models of exchanges. I am very close to finishing because we are all very hungry. Let me tell you, because you may know some of these people, how we started many years ago in the 80s with Horacio Guillo, who returned from his stay in Germany, and he supervised the PhD thesis of Manuel Cáceres. Manuel Cáceres just retired. He was one of the people doing hardcore physics in our laboratory still. So that was the beginning, and then supervised the thesis and work of many of us along decades. Eventually, we became a division in Centro Atómico Bariloche, which is now Física Estadística and Física Estadística e Interdisciplinaria. I don't need to translate it into English. And I wanted to mention also that for many years, the people that work in the field of neuroscience, computational and experimental neuroscience, neurophysiology, were part of our group, but then the Centro Atómico created a department of medical physics, and they all moved away. But they are still in Bariloche doing their work, which is closely related to the interest of many of you. People that you may know, like Inés Amengo and Germán Mato and Eugenio Urdapilleta, they are still at the Centro Atómico Bariloche, no, not longer with us. And finally, I want to mention, for the younger ones, that Instituto Balseiro has just received a very generous fund from Simons Foundation to fund 6 postdoctoral positions starting this year. So if you are interested, contact this address, simons@ib. Well, simons@ib.edu.ar. They will cover 6 postdoctoral positions in all areas of theoretical physics, including condensed matter physics, high energy physics that nobody cares of, and complex systems that all of us do. Okay, thank you. Let's go to have lunch.
Okay, thank you, Guillermo, very much. Any questions? No, people are hungry. Okay.
Sure.
Okay, so let's thank all the speakers of the morning and.